you, AES, for having me. We'll go ahead and get started here. Oops.
Why does the company exist?
Go back. There we go. So I'm going to give a little bit of insight of how we do Rivian design. This is a consumer-driven design process. And we're going to be going into the studio. That's primarily where I work out of. And kind of give a little bit of insight of how we use the XR, MR, AR to design our vehicles. Real quick though, I wanted our CEO and the founder to kind of give a quick background on what Rivian is. We are a new car company. We've only been out for a couple years, and hopefully a few people have seen them so far. But here's a quick little message.
Why does the company exist? What's its purpose? Why should the world care? Why does this company need to exist? It's simply not a choice to move off of fossil fuels. The only way to change it is to create products and services that are substantially better, but simultaneously more sustainable. Everything aligns around this idea of how can we add value to the world. The reason we saw the adventure space is it's the least sustainable type of vehicle on the road today. The wrong answer is to tell people that want SUVs and trucks that they have to drive really small electric cars. The right answer is to say, drive the vehicle that you want. Oh, by the way, this now has a path to carbon zero.
It's got sports car level performance on the road, but then to have the level of off-road capability with that is something that's never been done before.
Yep. So how do we operate? Well, we have a network of offices, test labs, and experience centers that all interconnect within North America. But we have a net zero commitment through our suppliers and vendors, and working together on a more sustainable raw material supply and aggressively managing our waste management. So you combine all this together, but where are our facilities? So a quick little map. This is where I'm based out of, is in SoCal, Irvine. And what you'll see is in the north part of California, we also have Palo Alto. Then we have our main factory in Normal, Illinois. Test Track, Arizona. A couple facilities in Michigan, and our neighbors in the north in Vancouver. And what you're going to see here is there's a lot of space in between. So we had a little bit of an issue. We had to travel a lot. Well, how are we able to travel? We can travel through the VR and through XR, which I'm about to go through. Real quick, a little bit about me, my background. I went to CCS in Detroit, Michigan, graduated 2009. Sorry, Dallas, for the recent loss. And then I joined Rivian in 2015 as the 24th employee. So I've literally seen Rivian go from 24 employees to 17,000. So seeing the whole architecture, we got to create the processes from the very beginning, how to create a whole ecosystem within a car company. But what I was able to do with starting so early was assist in the creation of surface and visualization teams within the design studio. We brought VR, associated digital tools, into the design process, and currently I lead all of the executive real-time VR and AR reviews out of our vehicle design team in Irvine, California studio. So real quick to go, if anybody doesn't know what the design process looks like, that's the typical clay model. That is a physical model that we actually walk around that weighs virtually a ton, that we hand scrape on. Now, this was a process that came from many, many generations and years and decades of automotive history. This was a slow approach. It took us a while to get the R1 product through this whole process of a typical design process. And that design process includes sketching. And a designer would typically use Photoshop, sketch it out, figure out what the theme was going to be, but you really didn't have any concrete CAD or any kind of modeling or anything of that sort. So that usually goes into what you'll see here, which is the design studio, to where you see this clay model. And so that sketch that you saw goes through a lot of iterations, goes through a lot of people, a lot of CAD work, and then it'll eventually get milled out onto the clay model. And then you start working the clay model. You start getting the aero teams involved. You start getting CMF, manufacturing, packaging. But that comes later after the process. So then we started looking at different tools. Obviously, one of the tools we use is Autodesk Alias. This is a surfacing tool that we're able to create the 3D CAD based on a scan or based on any kind of 3D component that can come over. And what you see here is just the charge port door that was surfaced on the R1T and R1S. Now, this took a while to even get to this point. And so what we saw was an opportunity for us to say, what if we were to do a little bit more sub-D modeling? The designers start with a 3D CAD real quick program, like Blender, sub-D with an alias, be able to create these 3D models. Well, guess what? We got 10 to 20 iterations immediately from this approach, same day. They were just proportionally moving the vehicle around. This allowed packaging, manufacturing, air, crash, CMF, all to get involved in the process so much quicker. This created the perfect digital twin. And so with that, we have a lot of designers now that are actually working within the CAD program that are actually just moving the lines organically. And what you see right here is, this is the R1T, but what he's about to do is move an entire body line that would normally take a week, 2 weeks to get that just right. And he's just moving the wheel flat just up and down, and it's carrying it with it. And so this is what we ended up doing. It was actually using the Vario goggles. This is a digital model. And as he walks around the model, he's interacting with it. He's able to actually look at the reflections without having to mill it out. And so what this gave us was a complete design approach that we could take those 10 to 20 iterations that were being developed by the designer into this 3D world, and we can actually interact with it. For instance, where is the charge port at? As she's reaching out, you can say, is this the right height level? Is this the right interaction? What's the physical vehicle actually going to do? How's the door going to interact with you? And we got to do all these. This is actually one of the things we're working on right now, which is doing 3D. This is me with the goggles on, actually scraping out clay model lines that we used to do physically. So we're starting to move into this very, very digital twin world that allows us to iterate a lot quicker. Another nice thing to do is when you start traveling around the world, these are all the locations I had to go through all around the world to raise awareness, obviously capital, but raise awareness, and I had to do all this in 2 weeks. I'm much more affordable to fly around the world than flying a physical vehicle that weighs 3 tons, clay. And so doing all that in 2 weeks, VR literally just proved it. It cemented itself into our design process. We were able to get all the data that we just saw, all those designers creating all that CAD, immediately update the model, showcase it to somebody, whether it was in China, India, or London, within the same day. It also allowed cross-team collaboration. Having the engineers be able to walk around what the vehicle was going to do, how the hood was going to operate, where the doors are going to open. What's the story that when you open up a door digitally, what do you look at? You look at the end of an IP, you look at the end of a seat. How do we design that so it's a nice, clean experience? VR and XR and AR all allowed us to do all this design iteration. It actually drove a lot of engineers crazy because we could see a lot more now, but it also created this very, very unique vehicle. And it really created this digital and physical unification. On the left was the digital model, on the right is the actual clay physical model. And so you can see how one-to-one this is now, how we're able to scan the materials, how we're able to iterate with the lighting, see things before we actually physically see it, make design choices before there's an issue. So going through some of the numbers real quick, let's say our development, right? So doing a clay model, as you can see here, we're working on the rear of the corner before we went digital. Development time, it took 1 week of milling. So just half the vehicle took a week per VR review, which would take an hour to set up. It cost about $5,000 of mill to mill it, just of clay, just for half the vehicle. And materials, the vehicle, is 325 pounds of material. So now you combine that all together. So through 1 year development, we have increased our iterations 2 to 3 times. We have saved over $1 million just being able to use the digital twin. And in material, over 32.5 tons of material saved, which is significant. So we've been a little busy. Real quick, 2023, here's our recap of what we've been able to do. So in just 1 year, we went to being able to produce our own motors instead of buying it from a supplier. We did 14 software updates over the air, 100% perfection. We were able to offer our electric delivery van that's currently delivering Amazon packages around North America. We are now doing that to the public. We're now offering it to the public. We tease a little bit of our future, which we'll just talk about here in a few minutes. To opening new spaces. We won the Rebel Rally through the desert with no GPS. We actually had to turn that module off, so we didn't cheat. And then we got the highest safety pick. All this began just because we were able to get the digital twin working quicker. We got these vehicles on the road quicker. In 2023, we actually have our own internal architect team, our own facility design team. We opened 2.3 million square meters across 135 sites in 1 year. We use the Autodesk Creative Cloud, or Construction Cloud. So the ACC, we're able to do that. So again, you're seeing this kind of from design to make using the Autodesk software. And then just in 3 years, we made over 100,000 vehicles. And that's really, really amazing. Just going from 24 people just a couple of years ago to 17,000 to create 100,000 vehicles already. But then there's 3 more reasons why we're doing what we're doing. And real quick, here's a quick little video of a preview. Video's not gonna work. These 3 vehicles we just launched this year in March. The R2 on the far left, the R3, and then the R3X. These 3 vehicles are gonna be going around the world. These are our handshake to the rest of the world. This is when we go from the R1 and the EDV, our electric van, to these 3. So this is how we were able to create these. So we'll go through with the R3X. Now what's fun is that's CGI, right? Because we got to start earlier because we had the digital twin. Now what you're gonna see here is this is our alias file. This is the transformation into the real actual vehicle. And what you can see is the one-to-one nature we're getting out of the surfacing. What we're gonna talk about next is the interior. And then as it transforms into the actual vehicle. So we're surfacing all of this in-house with about 80 people total in the design team. With the parts, the R2 required 378 unique parts. R3 was 362, and because the R3X was based off the R3, we did 89 unique parts. This was 839 parts that do not exist ever before. By the way, we did that in 10 months with 80 people. 3 vehicles. Those windows work up and down. Those vehicles drive up to 100 miles per hour. Those are actual working. We designed our own UI, UX on the screens. All the doors activate. Everything that you saw. No one knew. Everybody knew we had the R2. No one knew we were doing the R3 and R3X. And that was a fun little surprise that we did in March. So 839 parts. We only had 20 people on the surfacing team doing 3 vehicles in 10 months. So how we're able to visualize it was, let's take the R3 and kind of run through it. So this is a typical CMF tray, color, material, finish. We're able to actually take these materials, scan them into an AXF reader, and virtually be able to put it into a vehicle. Now, a lot of our reviews, I mean, most of our reviews are within the AR goggles, the Vario. And we're able to use that tray and be able to hold it with us using it. Now, this was me streaming from my house, to put this together real quick, but streaming from my house into the studio. So this is the actual R3 interior, using those scanned materials, being able to interact with the vehicle within an actual environment. Now you can see how you're getting the texture, you're getting the stitch lines, you're getting the actual CMF material of it. You're seeing where the button is to lower the tailgate. Things of that sort. These are the answers we would get from this technology. And then the result of it is the actual vehicle. And we got all these results without ever having to have, mock-ups built, physical properties. That takes weeks to months. A lot of money, a lot of material. We were just able to get the instant results. We never even took this vehicle outside to look at the reflections. That's typically what you do with the vehicle. And then here's the interior of it on the front. And that was just where you saw my hand going around virtually. But the biggest thing is how we share this. And going through the R2 is something that's going to be coming out first. We are able to share this with all generations. What we have in the studio is actually at our hubs that you can go put the goggles on. So for this was in Vancouver. They don't like having show cars come across the border, so we had to do something a little different. We had to actually put people within the goggles to be able to experience these vehicles. So the same models that we did to actually develop for the physical properties, we shared with Vancouver. And you can see here how people are interacting with the actual vehicle, how they're holding their hands against it, how they're actually pretending to be within the vehicle. This was a huge launch that we did with R2. And of course, at the very end, I always love to end this video. It's a really fun clip, everything R2, and basically what the Rivian company represents.
Hey, you ready?
That's good.
Well, thank you. I don't know if I have time for questions. I can't. No? Okay. Well, I'll be able to meet everybody outside. And again, thank you, AES, and thank you, everybody.